We had some questions on page 53 due for homework last night. Which ones do we need to go over? 13? Okay. 14. All right. Let's go over 13 and 14 then. 13 says a typical person can tolerate an acceleration of about neg 49 meters per second squared forward. Although that does depend, Cade, on how long that acceleration is exerted on that person, right? How long that force that causes that acceleration is exerted on a person. Boxers will experience an acceleration for a very, very brief moment in time, far, far greater than 49 meters per second squared. But it's for a very, very short period of time. A fighter pilot experiences an acceleration somewhere in this range often, but for sustained periods of time. So the longer the time, the less acceleration you can handle, right? The less acceleration your brain can handle. If you're in a car traveling at 110 kilometers per hour, I'm going to circle that right away before I even finish the question because I know I'm going to have to convert that. We have a collision with a solid immovable object. Over what minimum distance must you stop so as to not exceed this acceleration? Well, let's write down some givens here. We know that the acceleration here is neg 49 meters per second squared. We know that VI is 110 kilometers per hour. We're going to have to convert that, but we've got it circled in red, so we'll remember that. Do we know what VF is here? It doesn't tell us, do we? Does it? Or does it? What is it? 0. Yeah, it says it goes to a stop, so VF is going to be 0 meters per second. We want to find a displacement here. Let's convert the 110 to meters per second here. Let's say 110,000 meters divided by 3,600 seconds. Convert kilometers to meters, hours to seconds. Does anybody have a value for that? I think it's 30 point something, isn't it? 30.6 or something like that? 30.666? 555? Okay, there we go. This is a group B problem, right? It's acceleration, deceleration specifically, but which of the group B equations do we want to try for this one? They're all valid. Which one do you think is going to work the best? How about this one? A is equal to delta V over delta T. Do we know what A is? Sure. Do we know what delta V is? Well, pretty much, right? VI and VF, right? Solve for T, right? Except we're not trying to solve for T. We're trying to solve for D. Have I done anything wrong by doing this? Not at all. So I solve for T. Big deal. I wasn't looking for it, but it's not wrong. I haven't got a wrong answer for D. So I can either use that T in some other equation, or I can go back to square one and see if I can find an equation that fits these givens. Let's try this one. VF squared is equal to VI squared plus 2AD. We're solving for D here. Tricky to rearrange here. VF squared equals VI squared plus 2AD. Remember what we said the other day? Get rid of what's not attached first. What's not attached to the D here? Tell me what's not attached to D. VI squared is not attached to D. Now, it's a plus, right? Positive VI squared plus 2AD. So, because it's a positive, let's take it to the other side by subtracting. It becomes VF squared minus VI squared equals 2AD. Now, since there's nothing that's not attached to the D, let's get rid of what is attached to the D. The 2 and the A are attached to the D, and they're multiplied by D. So how do we get rid of it? How do we get rid of the 2 and the A that are multiplied by the D? Yeah, we divide them. So it becomes VF squared minus VI squared over 2A, divide it, right, equals delta D. Really what we're doing there is dividing both sides by 2A. VF is 0. So 0 squared is 0. VI is 30.566, 5556. I don't know what that is squared. Somewhere around 1,000, Sam? Over 2 times negative 49. What is that? 0 minus, that's 30.56, 5555 squared. Everybody have that? I get 933, negative 933.6419. divided by negative 98. So let's divide that by negative 98. I get 9.53, 9.5. So here's the good news. You can stop when you hit an immovable wall and be fine. Here's the bad news. If you stop over a distance that's smaller than 9.5 meters, you're not going to be okay. Now here's the problem. When you hit a concrete wall with your car, it's probably not going to be 9 meters that it takes you to stop. It's probably going to stop over something like a half a meter, which is going to mean the acceleration is much, much greater. And that's why we end up getting hurt, because we have an acceleration that's much, much greater than 49 meters per second squared. Make sense? You guys know that cars have crumple zones, right? Cars are designed to, the front end of them is designed to be destroyed, right? Well, that's so that you can take longer to stop, right? Bigger stopping distance. Let's say that the crumple zone is a full meter. Okay, it's a full meter, the crumple zone. What would the acceleration be? We could figure this out, right? We could say Vf squared minus Vi squared over 2d equals A. Let's use the same numbers here. 0 minus 30.5556 squared over 2 times, this time we'll go with 1 meter. What's my acceleration there? Figure this out. So if the crumple zone is a meter, then you're going to stop over a distance of a meter, and your acceleration will be not negative 49, but negative 466. Again, that's why it hurts when you hit a cement wall, because you stop over such a short distance. Make sense? You guys are going to learn this next unit, but what happens to your body stops pretty quickly, right? What happens to your brain? It doesn't stop. It keeps going. Well, then it hits your skull, and it stops and bounces back, and it bounces back and forth a few times in that process of stopping so quickly, right? That's why the brain doesn't usually handle that collision very well either. Okay, let's take a look at number 14. Determine a sub's acceleration if its initial velocity is 9 meters per second to the north, and it travels 1.54 kilometers in 2 minutes. We got units here that we don't want, kilometers and minutes. We'll circle those so we don't forget. The initial velocity here is 9.0 meters per second. We'll define north as positive. My displacement is 1.54 kilometers, and it's to the north, so it's positive as well. Let's make that 1,540 meters. Right? Kilometers times 1,000 equals meters. 2 minutes is my time. And of course, we know there's 60 seconds in a minute. At least most of us know that there's 60 seconds in a minute. So if we multiply 2 by 60, we get 120 seconds. We want to find the acceleration. How about Vf squared is equal to Vi squared plus 2d? I don't know which one to use. Let's try this one. Okay, we're solving for acceleration. That's good, because that's what we're looking for. It's in the equation. We know what d is, right? That's good. Vi, perfect. Vf, do we know what that is? We don't. So there's another unknown. Could we use this? You get 2 unknowns. So if you use this, you're going to have to use another equation in conjunction with it to get Vf. Okay? The easiest way to do it is to say, forget it. Let's not use it. Even though it's a perfectly valid equation, it's not going to give me the answer. So let's try something else. Let's try d is equal to Vit plus 1/2 At squared. I think that's the one we're going to use here. If I'm wrong, that's okay. We'll see that in just a moment here. Solving for A. Get rid of what's not attached to the A first. What's not attached? What's not attached to the A here? Tara, was your hand going up there, or were you just kind of scratching your head there? Vit. So let's take that over by subtracting, right? It's a positive on the right side. Take it over by subtracting. d minus VIT equals 1/2 AT squared. Now, what is attached to the A? Jazzy, what's attached to the A here? The T squared is attached to the A. What else is attached to the A? The half. We can take those both over at the same time if we want, or we can take them over separately. It doesn't matter. Yeah, I'm going to take them over at the same time just to save one step here. D minus VIT over all over 1/2 T squared. All right, we got D. It's 1,540. Subtract, to use some brackets here, 9.0 times 120 over 1/2 of 120 squared. We're going to pull out the calculator for this one, okay? Because a lot of you will make a mistake just in entering this one on your calculators. Let's say 1540. Subtract. Now let's use some brackets. 9 times 120. See what I've done there? I want the 9 times 120, and then I want to subtract that from 1540. I don't want 1540 minus 9, and then multiply that number by 120. Press equals. Now let's get the bottom. Let's divide it by, use some brackets there too. 0.5 times 120, and let's square the 120. Let's end off the bracket. So now again, I'm dividing it by the whole thing, not just 0.5. Press equals. We get 0.0639. Or we'd round that to 2 digits, because you see this is 2 digits, 3 digits, 2 digits. Round this to 2 digits, we get 0.064 meters per second squared. That's a pretty small acceleration, right? Yeah. Why do you think a submarine would have such a small acceleration? Right? Airplanes can accelerate way faster than that. Subs probably can accelerate faster than that as well, but why would this be so small? Yeah, you're in water. Like airplanes experience air resistance. Okay, and that's a problem sometimes. Air resistance is a problem, but it's not as big of a problem as water resistance, right? Because water is a lot more viscous than air is. Good? Any questions on that? Any other ones? On that works, you're on that set of check and reflect questions?